Hello and welcome back to Getting Started with BGFX. So in the last video we looked at the first of the three components we need to draw stuff to the screen, which is the index buffer. We looked at how and why an index buffer is needed. In this video we are going to look at a vertex buffer, which is the second component that we need to draw stuff to the screen. So a vertex is simply a point on shapes. We're trying to draw a square to the screen, so that needs 4 points, which means 4 vertices. And a vertex buffer is just a list of those vertices that we send to the GPU. So without further ado, let's get into it. Now let's get into our project. There are a few steps involved in making a vertex buffer. First, we need to include the GLM header so we can use the vertices. So if we go to the top, we'll go include glm/glm.hpp, and then we need to define what a vertex looks like. So I'll drop a couple of lines, we'll create a structure called vertex, then we give it a vec3 position. So the vec3 defines the position as a vector of 3 components, x, y, and z, so that we can position this particular vertex in 3D space. Next we give it a color. We'll give it a uint32 color. So each pixel has a color, and each color is made up of red, green, and blue and alpha, and each of those has 8 bits. So there'll be 32 bits total. Then we go glm vec2 texture coordinates. So a texture coordinate simply tells the GPU what part of the texture we want to use, and that goes from 0 to 1. 0 is on the very left of the image, and 1 is on the very right of the image, and it goes from 0, 0, x0, y0 on the bottom left to 1, 1 to the top right. So that just tells the GPU what part of the texture we want. Next, we need to create a vertex layout. Now we know how this vertex is laid out. We know that the first part of it is a position, which is made up of 3 floats. This vec3 gives us 3 floats. We know that the next part is 32-bit color, and we know that the last part is made up of 2 floats for the texture coordinates. But BGFX and the GPU and rendering API behind it doesn't know that. All it will see is a blob of data. So we need to tell it how to make sense of this data. So if we go down, and we'll do it after we created the index buffer. So we go BGFX vertex layout, and we'll just call it vertex layout. Then we go vertex layout dot begin. Then we go dot add BGFX attrib position. Then we tell it that there are 3 elements, and each of those elements attrib type is a float. So we're telling it that the first part of our vertex has 3 components, and each of those components is a float. So we go down, we'll go dot add BGFX attrib color 0. This has 4 components. Each of those components is a uint8, and we set this to true. So when it gets set to true, that means that it's normalized in the range of 0 to 1. So each of the components of the color can go from 0 to 255 in our code, but then this will normalize it so that it goes from 0 to 1, which is how we use it inside our shader. Then we go dot add attrib, and we give it a text coordinate 0. There are 2 components, and they are floats. And then we call dot end, and that will create our vertex layout. So here we're telling BGFX that the first 3 elements of the vertex are floats, and that they map to the position attribute inside the shader. Then it says that the next 4 bytes of the vertex map to the color attribute inside the shader, and the true here means that the red, green, blue, and alpha will be normalized so that they are from 0 to 1 inside the shader. And finally, the last 2 elements are floats, and that they map to the texture coordinate attribute. So if we go view this, there are all sorts of attributes that we can use inside the shader. We've got one position, we've got normal, we've got tangent, we've got 4 different colors that we can use, we've got 8 different texture coordinates. So we can expand this vertex to have multiple colors, multiple texture coordinates. This will become clearer once we get into shaders in the next video, how this maps to what happens inside the shader. Alright, now that we've created the vertex layout, now we need to create our vertices. So we're going to create a square, which means we have 4 vertices. Then we go vertices 0 equals, then we'll do -1 if this is the x, 1.0 if this is the y, 0.0 that's the z. So that whole part there we just done, that's our position. Then we create our color, so this one is going to be red, so we'll go 0x, we'll make this in hexadecimal, ff, so that means the color red is all the way on. Next one's the green, 0, that means it's off. Next one's the blue, again 0, that means it's off. And then FF for the alpha, that means it's completely visible. Alright, so we've done that one. Now we go to the texture coordinates, so we go 0.0, 0.0. So that means that it starts at the bottom left of our whatever texture maps to our shape. So that's the first vertex. We'll do the next one, vertices 1 equals, then we do our position, we go 1.0, 1.0, 0.0. So that is the top right of our square, so this is the top left and this is the top right. So then we give it a color. We'll give it a nice, we'll do FF 00, FF 00, 1.0, 0.0. So that is the right hand side of the texture. Then we go vertices, create a third one, 1.0, negative 1.0, 0.0, then 0x, ff, 00, 00, 1.0, 1.0, make sure that's F. I've done that. Oh, that's meant to be vertices 2, my apologies. And then we'll go vertices 3, this is our last one. Negative 1.0, negative 1.0, 0.0. So that is the bottom left of our square. And so we go FF 00, 00, 00 for our color. and we go 0.0f, 1.0f for the texture coordinates. Alright, so that's all of our vertices created. So now we'll drop a couple of lines. Now we can create our vertex buffer. So we go BGFX, vertex buffer handle, vertex buffer. So just like how we created the index buffer above, we can just go create vertex buffer. And again, we need to give it the data. So again, we're going to go make ref, because we're going to retain control of the vertices. So we need to make a reference to it, and then we give it the list of vertices. And now we need to give it the size of all of our vertices. So we go size of vertex. So that gives us the size of our vertex in bytes, and multiply it by 4 because there are 4 of them. Okay, so that created a reference to our vertex so that we retain control of the data. That means we have to destroy it once we're done. And now we give it the vertex layout. Alright, so once we've done that, we need to check if it's valid. So same as we did above, we just go is valid vertex buffer. That's false. And could not create vertex buffer. And we'll return 1, which means that we couldn't create it. And of course, once we're done, at the end we need to destroy it. So destroy vertex buffer. Alright, so we've done that. Let's run it. And we'll see if we get any error messages. Excellent, so we get a nice clear color still, no error messages. That means that the vertex buffer was created successfully. Now I just caught myself on this, I apologize. This is in the opposite way to the color that we use for the clear color. So the clear color down here is this part is red, this part is green, this part is blue, and then that's the alpha channel. For this, it goes the other way. This is the red, this is the green, this is the blue, and this is the alpha. So this means that this vertex will be red, this vertex will be green, this one will be blue, and this last one will be black, because all the colors are off. Okay, so just be careful of that. Sometimes it goes this way where the red is at the beginning, sometimes it goes this way where the red is at the end. So if the color doesn't match what you think it should be, then just check the reversal of it. Alright, so that's it for this video. So in the next video we will be creating our shader, and we will finally be able to see something drawn to the screen. So I'm going to push everything to GitHub, and I will see you in the next video.